Good morning. Welcome, everyone. My name is David, and today we'll be talking on the topic security considerations for MLOps infrastructure on AWS. And hopefully, we'll go ahead to maybe provide some clarifications around MLOps, and yeah, hopefully it's valuable to everyone as well. So we'll start by discussing why this is really critical for businesses. And to understand those critical aspects of ML and AI security, one of the cases that just happened a couple of months ago, where Air Canada lost over $800 million to a small claims court with hallucinations in AI. And we pretty much see this happen over and over, with some companies losing billions of dollars and having other impacts on businesses. Not just Air Canada, the case for Zillow as well, with the business making really critical, leveraging AI to make really business critical decisions, and maybe essentially having issues as a result of that. And here we look at some of the impacts of those bad decisions, or those security breaches, which AI, has made on businesses. One of them being financial loss, and in some cases, reputational damage, and sanctions and fines, as well as for the case of Air Canada, as we've looked at as well. Some cases, bankruptcy, and in extreme cases, could also lead to loss of lives as well. So this pretty much highlights some of the critical, aspects of AI and ML. So, and also I'd like to point out that in the case of this, across this presentation, I would use AI and ML interchangeably. So when I mention any of them, I'm pretty much referring to almost the same case, but yeah. So who am I? My name is David. I'm a software engineer. I specialize in DevOps and MLOps. Pretty much, both of them are similar, but we'll dive in a little bit to understand how both of them differ from each other as well. Yeah, in my spare time, I like to play ping pong and also enjoy playing video games as well. So in today's talk, we'll first of all try to understand what MLOps is, understand the security challenges and vulnerability classes of ML systems, and also we'll discuss about some of the best practices for implementing these security configurations on AWS. And then we'll look at some further readings and some AI and ML frameworks as well, which everyone can explore after the presentation for their own personal use case as well. So we did say that we'll discuss what MLOps is. Over the years, companies have sought ways for them to merge or find a common ground between development and operations, and it's worked really well. Not just changing the culture in which software is developed, and how companies actually make software delivery more iterative process, and also delivering features faster to businesses, and ensuring that customers don't have to wait long hours or long days or years probably to see new features in their software. So the same thing is also being applied, or the same concepts and principles is what we are bringing over to the ML system, which has been coined together to make the word MLOps. So it's pretty much, DevOps is the same concept that applies to software engineers is what MLOps applies to ML engineers. So what MLOps is essentially is the same set of software principles or software development principles and cycles for developing ML systems, applying those software principles into the ML system and ML space, essentially. So we'll talk about that, and hopefully we'll provide some clarifications. So yeah, but before we go ahead, is anyone in the ML space in the room? Oh, great. Yeah. So how about those in DevOps or related field as well? Great. Okay, cool. So yeah, so this, a number of you would understand, to some extent what I'm actually talking about as well. So it's pretty much, MLOps is pretty much, understanding the cycle of, starting from data preparation, development of the data, exploratory data analysis, up until the point where we deliver the ML models to production. And today, we'll talk about some of the security implications that would consider when building out such systems as well. So what we have here is what a typical ML infrastructure will look like, the ML ops pipeline. So we have our data storage. So within the data storage, it could be RDS databases, or maybe data lakes, maybe Redshift, or if you're using AWS and some other storage systems, essentially, which your business used to collect the data from the customers and store those data in some form or the other. So the MLOps architecture essentially provides an automated process for us to get the data from the source, from the different sources, and then do some data preparation, data pre-processing, and use the data we have to develop and train an ML model, and also to the point where we develop and deploy this model to production as well. And it doesn't just end there. When those models are deployed to production, we also need a way to, serve these, ML models which we've developed for use for applications as well. So we also look at that aspect as well when developing a holistic MLOps architecture. From applications ingesting or using those models to also monitoring those ML models for drifts. And when they deteriorate, we also have to automate the process of actually retraining those models, ensuring that the models are also up to date as well with the new data we get from our business. And also, somewhere we'll also have to store our dates, our code as well. We also, in a code repository as well. So this is pretty much a typical MLOps architecture, what it looks like. However, businesses have adapted this system to suit their specific use case. You could see either this or a variation of this being applied to businesses. But yeah, this is what it looks like holistically as well. So first of all, let's look at some of the vulnerability classes which you might want to consider when looking at ML systems. So the most popular ones these days, or the most common ones you probably see when talking about ML security, are ML-specific ones. In cases like ML model theft, prompt injection, manipulation of inputs, data poisoning, and some of these. These are specific AI and ML-related vulnerabilities, which as a business you might want to consider as well. However, beyond this, we also have traditional software vulnerabilities as well. So this looks at, because ML systems and MLOps systems are typical softwares, we can't run away from the typical security vulnerabilities which apply to typical softwares as well. So another class of this is pretty much the traditional software vulnerabilities like authentication issues, privilege escalation, supply chain attacks, and DDoS attacks as well. And also, the last bit is pretty much the infrastructure vulnerability. So the infrastructure vulnerability is part of what we are discussing. And we'll also talk about or touch on each of these aspects of the vulnerability classes in ML systems as well. So yeah, let's carry on. So for traditional software vulnerabilities, one of the key places we, as software engineers or people working in software industry, the OWASP top 10 vulnerability provides a number of top vulnerabilities which you would want to look at or consider when building out traditional software. Like we mentioned, security for MLOps systems or MLOps security is not just security for specific AI systems because, like we mentioned, ML systems are essentially software, so we have to look at the holistic security, both the ML-specific security, traditional security, and the infrastructure security. However, for companies that look at building out traditional software, the OWASP top 10 provides some of the common vulnerabilities which companies usually look at, and the most recent one is the 2021 one, but there's also the one for 2025, which is also in the works, which everyone might actually have a look at on their website to see the most recent one once it's released as well. And to understand specifically how traditional software differs from MLOps vulnerabilities, the MLOps systems provide, gives us, it essentially extends the possibilities of attacks or attack surface areas, which makes it not just a simple, it makes it not just a simple, looking at the traditional software vulnerabilities for systems, software systems, but also going beyond that to look at, the complex lifecycle for AI systems, and also looking at AI supply chain security as well. Because with ML systems, it introduces a lot of, surface area for attacks. And these supply chain securities, because we use a lot of images which are provided either by open source communities or softwares which are provided by open source communities, you open source up to different ways which our systems can be compromised. So we'll look at some of these bits in a bit more detail as well. So next, let's look at some of the security challenges in ML systems. So the first bit is looking at the data security. ML system or MLOps system is pretty much around working with data. As an ML, as an ML specialist, you're essentially working with lots of data, sometimes petabytes of data, terabytes of data, depending on how large your organization is. And data security is a really critical aspect of building out secure ML systems. So some of these are, some considerations we would want to actually look at to ensure that our systems are secure. One of them being, data leakage, risks, misconfigurations for your S3 bucket, adding too much permission, or, accessing data that, is publicly available without using trusted sources, as the case may be. And also having, unencrypted data as well. In some cases, your organization will probably be, have access to PII data as well. So it's really critical, to ensure that data security is at the top of your considerations when working around ML systems. So sometimes you might get away with, having plain text secrets in a development environment, but that's not acceptable in building our secure ML systems pretty much. So our system has to be stored in places where, the secrets and, sensitive data has to be stored securely in their respective system. Thankfully, AWS provides us with a number of these systems or services that allows us to store our data securely, and we'll look at some of them briefly as well. So next is the model security. For us to protect, build a highly secure ML system, we also have to look at like we mentioned earlier, supply chain vulnerability as well, because ML space is filled with a lot of open source data, open source software, we have to also be careful and build out our systems in such a way that, we, take software or use software from, very secure sources, to build our system. And also there's the challenge of model theft, and, IP, IP, issues as well. So which, we also have to put into consideration when building out our systems as well. So we also have adversarial attacks, these are essentially vulnerabilities that make our machine learning models to make wrong predictions pretty much. So some cases probably be called hallucination, where you pretty much get wrong predictions, whereas you know that this is not what it's meant to be. So these are some of the considerations, like we mentioned earlier, which opens up a surface area of attacks, as our system can now be attacked from more ways more than ever, pretty much. So we also have the issues of biases and fairness, in places like maybe hiring, or in some cases pretty much, depending on the industry as well. So next we talk about pipeline security. So with the typical DevOps systems, we are able to build out CI/CD pipelines for our system to build, to deploy maybe our code base from a Git repository up onto maybe a dev environment, pre-prod, and maybe a prod environment. However, beyond the CI/CD pipeline, for typical softwares, MLOps, you also have to implement, especially for production cases, you also have to implement ML-specific pipelines using specific pipeline tools like SageMaker pipelines or Airflow or Metaflow, depending on what your business uses for those orchestrations. So those are specific, those, like we mentioned, the open source, it opens up more ways for our systems to be attacked. And securing our system for such cases is really critical so that we protect our business, our intellectual property, or whatever we are building as well. So things like fragile code and lack of code versioning. So I don't think the lack of code versioning is a case for businesses, but but because of the fact that data science, we started out as data science, working within notebooks and running maybe large model training within notebooks. We also have to consider working beyond just within notebooks, right? It's good to actually do your experimentation on the notebooks, but however, putting or building out secure systems requires you moving out of the notebook world and building out systems that are able to run in an automated fashion, so that we'll be able to also version our code, as the case may be, and also implement some best practices while we're coding out our system as well. So just like we mentioned, with working with notebooks, we pretty much, sometimes we pretty much use some practices which might not be the best practices because it's easy to run different cells and maybe not put our codes in a function or something like that, or something in a similar fashion. But yeah, working beyond just the notebooks allow us to build our software that in a standard way that it provides teams a way for them to manage their code base in the right manner as well. So we also have insecure authentication as well. So when you're building out your pipelines, also making sure that the correct services have access to the right data and the right permissions to actually perform the operations that they need, and only the permissions that they need to perform their operations as well. So the next we'll talk about deployment and serving security. So once we've built out our infrastructure, we want to provide the model for applications to use them, or maybe for users to make calls to the API endpoints that we've deployed. So pretty much, we need to also secure those parts of our infrastructure as well. So we need to protect for things like output manipulation and for DDoS attacks as well. And also, one of the very common cases we usually see these days is cases where PII data leaks from models, pretty much. So, someone could actually, try to manipulate your model to bring sensitive data from your business. So it's really critical to understand, to implement measures to prevent such cases from happening as well. So next, we'll talk about some of the best practices which will be really important for us to implement, not just within AWS, but across different cloud environments. Pretty much some of the services we'll be talking about might also be available not just within AWS, but also beyond, in other cloud environments as well. So the first bit is actually implementation for the governance around AWS. Within AWS provides us things like AWS organizations, IAM policies, and control tower. And these are governance tools that allow us to, build out our systems in such a way that, we have, permissions or policies that restrict how we operate the services that we operate. So if you're working with say for example, in a large organization where you have tons and tons of AWS accounts within your organization, so it's pretty much, a basic step to set up AWS organizations so that, you can apply policies at the organization level, and you can also implement things like service control policies that allow you to restrict how, users maybe access specific services within within the AWS organization. So, like I mentioned, pretty much some of these, tools which are provided by AWS gives us the flexibility to implement restrictions pretty much. Restrictions could be around the organization units. So AWS has a concept of the organizational units, and it's basically a way for you to bunch a number of AWS accounts so that you can apply similar policies for them or apply similar restrictions on those accounts. So, your system is actually built in a secure way as well. So you can also, leverage AWS config to, run periodic checks to ensure that users within your organization are using AWS in the right way as well. So you can have, either managed AWS config rules or custom config rules as well, which you could possibly develop for your own specific ML use cases. And also, interestingly, some industries like the financial sector also have ways of adapting AWS config to their specific industry use case to ensure that teams are compliant to industry standards as well. So yeah, these are some of the governance tools which AWS provides. And also, for similar cloud environments, we also pretty much would have other governance tools which those cloud environments provide us to manage our, our accounts as well. So the next consideration also is IAM. So IAM pretty much allows us to apply fine-grained permissions to specific AWS services. We did mention about SageMaker earlier. So SageMaker is a tool within AWS that allows you to build out, SageMaker pipelines, specific ML pipelines or MLOps pipelines pretty much. So you can build out training jobs or data transformation jobs or processing jobs, which allows you to, perform different steps within your pipeline pretty much. So with a well-managed or well-designed IAM identity center, IAM configurations for your AWS accounts, you're pretty much able to implement things like temporary credentials as well, and role and specific roles for things like your execution jobs or your processing jobs. So when implementing this, it has to follow that like the least privilege policy of AWS, so that it only has the permission to perform the operation which it needs to do as well. So the next we'll talk about is the network security as well. So with AWS VPC endpoints, it allows us to interact with other AWS services like your S3 buckets without having to traverse the public internet as well. So it allows you to maybe get data from your S3 buckets or your DynamoDB tables and access other AWS services as well. So, and also we can actually implement security groups as well, and network access control lists as well to restrict resources within your AWS as well. So we also have the web application framework and shields for protecting your API endpoints as well. So this allows you to provide like network security around your application and your infrastructure that's deployed within AWS. So the next one we talk about is the data security mitigations as well. So we talked about data earlier. However, beyond just the data we talked about, we also have the considerations for data encryption, where it's critical to ensure that your data is encrypted both at rest and in transit as well. And also have like tools like AWS Messi that allows you to detect sensitive data within your S3 bucket as well. And also considerations like data versioning. This is really critical so that whenever you're building out your system, with your data versioning, you're able to track what version of your data produced a specific result. So it not only helps developers to make their work more efficient, but also as a business, it provides you with information about how to make your improve on your business. Your data scientists could actually play around with the hyperparameters for your system and also ensure everything is fine. So we also have data policies as well and data validation. Sorry, we just have 5 minutes more, so I'll probably run through the rest of it. So we also have model security mitigations as well. Using AWS model registry and managed Airflow as well, and automated bias detection as well for explainability. And also, one other critical aspect of infrastructure is actually the monitoring of your system as well. So I know a number of data scientists usually see monitoring as an afterthought, really, but that shouldn't be the case anyways. With monitoring and incidents, with monitoring and logging of around your infrastructure and your systems, it allows you to, in an automated fashion, retrain your models and also, put guardrails in check so that if anything goes wrong, you have visibility around what went wrong and how it went wrong and how you can also resolve those issues whenever they happen. With AWS CloudWatch, CloudTrail, and several other AWS services, we also are able to keep track of all of that. We also have pipeline security for implementing things like code integrity, hardening your SageMaker pipeline like we mentioned earlier, and also implementing end-to-end tests as well. So this is also one of the things I've noticed that data scientists as well implement as an afterthought, implementing tests within their infrastructure. So like I mentioned, working beyond just the notebooks allows you to implement these best practices by implementing like unit integration tests and end-to-end tests as well. So for your endpoint security, we'll consider things like rate limiting the number of queries that are made to your endpoints as well, and implementing guardrails for the users of your application, and also DDoS protection as well. The last one. Yeah, don't worry. I'll share the slides after the session, so everyone will have access to them. So let's quickly look at some of the implementations which we talked about. So the team effort, MLOps is a team effort, right? It's not, just like DevOps, it's not something one person has to do. It's a team thing. It involves different parties, people like the product owners, people in charge of model approval, people in charge of the data layer, and also the platform engineers. It's all around having different team members working together to ensure that their system is essentially really secure as well. So it's a team effort. And implementing MLOps is the people, technology, and process working together to ensure your systems are efficient and also secure. So the intersection there is the MLOps we are talking about. So lastly, we talk about secure by design. Here we have a number of AWS services which are different stages of the MLOps infrastructure pipeline, which we mentioned earlier. We have AWS-specific services that allow us to implement those specific things we mentioned. Like you have your AWS inspector, your KMS for your encryption as well, your VPCs and all of that. So your IAMs. So here we have a specific architecture that allows us to use the AWS provided service, SageMaker AI, to deploy our studio domain within a private subnet. Within this private subnet, we can write our SageMaker pipelines to interact with AWS services. We can see that each of the endpoints within this private subnet, we can interact with an S3 bucket, a CloudWatch, SageMaker API, our runtimes, and feature stores as well, all via endpoints as well. So this allows us to interact with our other AWS services without having to pass through the internet as well. So, yep. So we'll quickly rush through the rest. So this bit is about the well-architected framework. We all aware of the well-architected framework, which allows us to pretty much, look at the different considerations when building out secure systems in AWS. So the security aspect is really important. And then threat modeling our system, which is great. And the shared responsibility model. Yeah, I'll share these slides so you can have access to them later. And if you have any questions after now, feel free to reach out and we can have some conversations after now. So thank you very much.